Hello.
Hi.
Yeah, it seems we are on stage. Yeah. So we are starting with our first talk today, and I'm Andrei. I'm host of this talk today, and I want to introduce Max, who is going to talk about Kubernetes. Max is founder and cloud native advocate at company Liquid Reply. Cloud native advocate, like sounds like Jesus, right? And Max is going to talk about do we really need Kubernetes? Sounds quite provocative. So probably you are not cloud advocate, but you are cloud provocate. I guess so. So yeah, Max has a great experience with Kubernetes and open source projects and so on. So Max, you can start.
All right. Thank you very much, Andre. That's indeed always a little bit the big question. I'm an advocate, I'm a provocate, but I think in the end it's always about to find the right solution. And maybe Kubernetes is not always the answer. Also, I really love to work with Kubernetes and spent the last years working with Kubernetes. So to round a few things up from the introduction, beside my job as an advisor for cloud native technology, I'm working a lot in open source. I founded the technical advisory group for environmental sustainability. I'm part of the CNCF ambassador program and also part of the Linux Foundation Europe advisory board. So all day long, somehow something with computer and open source and whatsoever. If you're interested in some of the other topics, feel free to follow me and get in touch with me, and I'm happy to chat about it. So today we're talking a little bit about Kubernetes, and I'm pretty sure a lot of you have seen memes like this. People expect like a heavy, beautiful sunny weather day with a Kubernetes when everything is up and running, but often the reality for teams looks a little bit different, looks a little bit more problematic, a little bit more, how to say, everything is a little bit burning, everything is a little bit challenging. And overall, that might be the reality, but it has reasons why it end up like this. And usually if you do the things right and you're on the happy path, then the expectation most of the time comes true. But as soon as you leave this happy path, you obviously have some problems. Now, you see, there's tons of jokes about like, hey, we use Kubernetes now, and then asking like, hey, why everything's getting more simpler and whatsoever. And he's like, for sure. I'm pretty sure you maybe remember the scene from Star Wars at some day, but this is really like the average happening for many teams that start adopting Kubernetes and first get hyped and get introduced to, and then suddenly hit the wall of reality. But again, it has a few reasons which we will discover later. So when people talking about Kubernetes, they always compare it with container ships, which is a large vessel and has huge complexity and ships tons of stuff. And actually, it's not that flexible and things like that. I would say that's not really Kubernetes, or not only, but there's other perspectives how you actually can tell the story. So for me, when we talk with people about their Kubernetes experience, it's more like a Lego set. You put things together which you like and which you need, and which makes you fun to have, and which you, in the end, need to implement to tell a story to whomever may this concerns. And this Lego principle behind it is, I think, a little bit better picture. However, in the past, I was usually said like, hey, this container picture doesn't fit at all. But I would say it's more like a mix of both, right? It's a mixture of like, you have a Lego container ship, which you can adjust here, like the Kubernetes line, to what you really need it for. Because what people underestimate with Kubernetes is when you introduce it to a bigger organization, it has the potential to replace a large part of the infrastructure, and it become like a container ship. Because you maybe also need to think about the I would like to say, positive side, which it has. Similar to containership, these are often operated by a relatively small crew. Such ships have something between 15 and 25 people for it. But the value which they transport can be billions of euro. If this container ship stuck, if this container ship sink, you lose tons of money, right? But Kubernetes makes it very hard to make it think, like modern ships too. So I would say, meanwhile, this analogy somehow fit, but we need to be a little bit more creative in how we see the overall story, because this ship can be extended through other things, through our Lego world. Now, why does now Kubernetes fails, and why we have, and see often that there is a problem with it? And there's a couple of good reasons for it. When you search the internet, you can find very interesting discussions with a good amount of traction and quotes, and the overall tenor is like, oh, there's a couple of things which are very hard. However, if you go into the details, it's usually not the platform which is the problem. So it's usually not Kubernetes which is failing, but it's often a lack of knowledge, or it's often some subcomponents of this whole story. And this makes it quite interesting. Now, when we think about the reasons, there's often wrong roles. We have the DevOps movement in the last years. I personally believe a huge part of it is bullshit because it's done wrong. Maybe you have read the book from the DevOps on the Phoenix project from Jess Humble, which when I read it, I was like, well, that's what we need. We need this mindset change. We need this organizational change. We need to open up. We need to reduce our bottlenecks. In my previous company, we had, for example, one guy who was able to set up virtual machines. Only one guy. And in summer, he could every year goes 4 weeks for vacation. And he becomes this bottleneck because in summer, we strategically plan to not launch a new project, a new system, because we will not get a new virtual machine. And to replace that person, not replacing of like getting rid of him, but take him out of this responsibility and put 2-3 more people into it whom he can teach. This is a DevOps mindset. But what we do out of it is like we have the expectations that somehow developers will do the platform operation. I think Werner Vogel said 2006 or something, you build it, you run it. That's partially correct, but we interpreted it completely wrong. People think about you build it, you run it from the full zero, from the front end to the last bit and byte in the network and everything in between. But that's completely wrong. And we see that this fails over and over and over again. And the adoption in organization also fails and corrected. Rather than to rethink what they are doing, they rename it. Then suddenly you have not only the DevOps team, but you also have the site reliability engineering team and so on. So when we take a look about what people do when they're searching for problems, Stack Overflow is actually a funny source of it. So I searched here for a couple of topics like Cloud Foundry, OpenStack, and so on. And you see the amount of open questions to it. Cloud Foundry, 3,000, OpenStack, 2,500, AWS, 150,000. Well, okay. vSphere, Hypervisor, VMware, 4,000. Kubernetes, as you saw also in the first screenshot, almost 60,000. So the question is now, why there is such a difference between a Cloud Foundry, an OpenStack, or a hypervisor towards Kubernetes? And this is because, on the one hand side, people don't understand the platform correctly. On the other hand side, the roles are seen wrong. Yes, Kubernetes allows developers to do things better, faster, more automated, more standardized. But it's not the developer responsibility to manage Kubernetes. This is completely wrong. That's a wrong perspective of doing the things. But this is what we see in the large organizations, that they force and ask developers to maintain and run everything what they have developed. And so they will fail at one point in time on Kubernetes. And the same thing actually also happens in the cloud environment, where people still get asked like to run something on cloud. The problem here is that most enterprises and most companies have at least 2 to 3 cloud provider. So you actually don't need to learn once, but at least twice, and then in Kubernetes and containers, which is thrice or 4 times. And then you maybe have also an on-prem environment. So the whole thing gets very complicated. We call this also cognitive load. The cognitive load is large for developers. And if we try to put this all out and stretch the problem, understand each single string in this problem case, it's not very, very simple to answer. It's really complicated because it's a thing of mindset, role definition, demographic change, financial pressure of companies, pressure towards development and platform teams, and so on. So the complexity behind is completely insane. And that's because we have this big misalignment in the end. When we take a look at developer and we take a look at operations, this model works actually very fine. Misinterpreted, DevOps putting together, it doesn't work fine anymore. I elaborate a lot of these points which are written here, but the main thing is like when you go and develop as a developer and want to put something on Kubernetes, you often have the problem that you need to understand a lot of complexity, you have a long learning curve just to make a little bit code running, which is insane. If you think back to times where you maybe used Heroku, you just throw your code and it somehow magically runs, right? Why we don't have that? Well, the answer is you can have that if you have a team which maintains and builds such a platform for you. And yeah, so let's move on. I recently found this phrase and I found it very genius, which says like, you don't ask a watchmaker to build a global watch factory or factories. And this actually describes very well what we nowadays see all the time when we talk about DevOps, right? You're not going to a developer who, let's say, make it more precise. We don't go to a backend developer specialized in writing Go or Java with Spring and has a very good background in manipulating data and working with data in this case. You not go to that person say like, oh, you're now DevOps, and now I would like to help that you build me a thing that goes all around the globe, and you need to understand how all the networking works and how all the multi-tenancy works, how the security works, and you need to take care about the costs and so on. This doesn't make sense if you go deeply into this and you just speak out what do you expect from that role. It doesn't make sense. So maybe that's the first thing which you can take with you, that a watchmaker is not someone whom asks for building global watch factories. Now, the second reason is that we have a very poor support. We usually see that there's either no time or no budget for proper trainings or for the discovery phase. And that's very sad because the best way how a human can learn is by trying things out. But it works well when we try things out because we are curious. It doesn't make fun if we try things out because we are pressured for it. From the Cloud Native Computing Foundation report, also 46% of all the asked companies and people answered that they have a problem like in trainings already now. And that's a number which is continuously at this level over the past years. So no time, no budget. We need to do things fast. We had a few years back a very large project where a customer came to us and said like, hey, we have 4 months and we need to be productive until the end of the year. We need to build the full platform. We need to migrate tons of applications. Everything is mission critical. And if we fail, we have a really, really big problem. So actually a very common problem, right? Everyone has this all day long. But that's the wrong thing to do when you want to introduce a new technology. I'm pretty sure when 30 years, 20 years ago, maybe 15, you introduced hypervisor to your infrastructure, no one was saying like, oh, I expect that tomorrow you have installed everything of this technology, which you have never ever seen before. Yeah, it's completely unrealistic. But that's how the world is. And now, the most paradox thing which I meet is like, we don't need too complicated, too big trainings. I was once with an organization talking about like, hey, what is your certification path? How do you, and not for the sake of certifications, just as a proof of work, but how do you train your people? What is your plan for it? How do you have a thought process behind it? Do they learn cloud? Do they learn container? Do they learn Kubernetes? Do they learn everything on top of Kubernetes? And the answer to it was like, no. Why? That takes too long. If I do that, my people needs a month to be trained. And I was like, yeah, that's right. You need some time to train them because people fail already on cloud, how they should manage then Kubernetes. And organizations don't want to invest into that because it would mean that they lose a lot of time for building something. So they keep pressure and driving things forward and expect that someone can learn while they have this pressuring environment, while they need to deliver every 2 weeks some releases and so on. It's already, when you realistically think about it, it's meant to fail. It's similar like you come to a hospital and someone tells you like, oh, you're going to be a doctor and you're going to operate tomorrow someone on the open heart. And you can learn that on the way. That's not a problem. For sure, in a Kubernetes environment, no one maybe will die from it. But it's the same. You would not go to that person. You would not even trust that person. Why you should do this then with your own organization? This leads to that we do the wrong things. Often we see the teams failing with somehow the integration between the development, security, observability, especially if we talk about multi-tenancy, it's getting complicated. And this overall raises frustration. So you lose the people. And then the last piece, even if you manage somehow to overcome all of the problems, is that you over-engineer, or that we see a lot of people over-engineer because they misunderstood Kubernetes and for what it is made for. And then teams dig down drastically into what they could implement and completely lost track of what they should do. They found a little problem and introduced 2-3 solutions for it, which could be also solved in another way in a shorter amount of time, being more reliable. This leads to one problem with the Kubernetes that we see always is rumors about, oh, Kubernetes is so complex, it's always adding up costs and it's difficult to manage. Maybe, if done right, I have never seen that. We have seen a couple of very large organizations that introduces Kubernetes as a main runtime over the last years. And where this platform is adopted from the whole organization, the teams doesn't increase. They always stay around 9, maybe 12 people. Sometimes they get 1 or 2 more people to it because they run clusters globally. They run systems in America and in Asia and in Europe and a different time zone. So it makes sense to have someone who's always on a shift, and this is why they're done with more people. But the team doesn't grow because of the complexity. The team doesn't grow because there is more workload on it. Right. So if it's done right, you don't over-engineer it, then you don't build something which is too complex in the end. And so it's actually a little paradoxical problem that people think about over-engineering and over-engineer it. So the result is that they complain about that it's too complex because it got over-engineered. Just keep it simple. Keep the things simple. You may know the KISS principle, KISS Kubernetes, something which went stuck in your head. So give a kiss to Kubernetes and then you will have a very easy life. And yeah, sometimes you even will fall in love into it, even if it sometimes feel a little bit stupid and dumb and annoying you. But in the end, it's just a lovely creature, right? So what about all the other problems? Well, if you take a look on the market reports, what is the problem with Kubernetes? They also talk about, for example, security or the operational overhead or the complexity. But in my opinion, from what I've seen in the past, these problems appear because of the other reasons. The problem of Kubernetes security is not because Kubernetes is unsecure. It's because the people don't know how to secure Kubernetes. In my world, we are not specialized in doing too much security, at least like a few years back. But nowadays, we do a lot of security advisory and implemented very hardened environments, helping to secure the network, to put in hard multi-tenancy, to be very precise with user access and stuff like that. And for me, it feels meanwhile it's an integrated part of the platform. So you need to learn this obviously also. Yeah. Talking with security teams, it doesn't matter how good or worse the organizations are, usually they have absolutely no idea. They have already problems understanding cloud. Then comes containers, they're off, and Kubernetes living on another planet. I don't want to say that there's just organizations who have no idea about security, but I can understand that in a world where you have such limited amount of people available who can help you, it's difficult to keep up with such development. So I see this as an integrated part of a team who implements Kubernetes, for example. And this counts for operational overhead and complexity and other problems too. You can have your team taking this over without a problem if you help them to understand it and learn it and how to do it. Right. So this leads us to the question, when is actually Kubernetes wrong? And I need to underline here again that no one ever said that Kubernetes is a solution for everything. When I'm on different conferences, developer conferences, cloud summits, I often hear like, "Oh yeah, but you're a Kubernetes guy, so what? Why everyone wants to have Kubernetes? Why we just don't use VMs or serverless?" And it's like, "Oh, you can, right?" As a good consultant, I always would say like, it depends on. Because Kubernetes is not always the right solution, especially if your organization has limitations, and we come to them in a while, then maybe you should go for something which is easier to understand, which is the first reachable step for your organization. So to keep themselves short, when you have commercial software, Kubernetes is often, not always, not the right system. We face that commercial software requires a lot of Windows. Sometimes it maybe can go on Linux. A few more solutions are going on being containerized, but even there we see funny development that they can run a container, but they're very difficult to run on Kubernetes because they're not able to scale that way, they're not able to run in parallel, and so on. So usually buying some random software often leads to that you cannot run on Kubernetes. Then the classic, a large monolith. They could run on Kubernetes. That's not a problem. We have done all these dirty things already. It's possible. You have a monolith which needs 20 minutes startup time, re-indexing things and organizing itself somehow until it's preheated and ready to serve. It will work. I have no worries, no doubts in it. But the platform is not made for it. Not that Kubernetes is not stable. You can run these things forever without any problem. The thing is that you have a proper release cycle within Kubernetes. And I personally believe you should follow this release cycle and be able to run the 300-400 updates for the Kubernetes cluster and all components on top over the whole year. If you have a single application that prevents you to update, take this application off. Yeah. That's two different worlds. It doesn't fit together. It's like you want to run with a VW Bulli bus against a Maserati or whatever. It's two different things. Memes. Memes. When your team shows already that they're against this technology, your team has a bad picture, usually they often don't have the right understanding or any understanding at all, but continuously make joke about it, I would recommend you not to introduce your Kubernetes, because then you first have to change the mindset, then you have to introduce the technology. It's complicated to motivate people to work with a technology which they don't like, even they have never worked with it. If this is successful, you have the biggest fans for it. It's not like that. But the way for introducing this successfully is super duper long. and you most likely will lose over that time. And yeah, you run a container somewhere in some way, and you're happy with it, then why you should change it? And recently I had a discussion with an e-commerce provider who currently runs everything on Docker Swarm and a container, and asked me like, hey, do you think it makes sense to upgrade to Kubernetes? And I said like, no. Like, yeah, but you are the Kubernetes guy. You build platforms. Why you think it doesn't make sense? And the answer is, well, you are happy. You do not have limitations. Do you need anything from Kubernetes? Do you need the network encryption on the platform? Do you need that it's self-healing, that it distributes your workload? And they're like, no, we don't need it. But we just thought like we get more mature if we go to Kubernetes. Well, that's wrong. You're not getting more mature if you go to Kubernetes. You can be very mature running things just in a container if you want. Kubernetes is not always the right solution for you. So for me, nowadays, this discussion also feels sometimes, I'm sorry to say, very stupid, because people think too small. They think about Kubernetes. When I'm talking with cloud people who come with serverless and managed Kubernetes and managed container and whatsoever, I don't want to compare that. You're like comparing a full feature set of a couple of hundreds of services with a bare infrastructure that allows you to plug and play whatever you need. How you want to compare that? It doesn't make sense, right? So Kubernetes is not your target infrastructure. It should not be seen as your target infrastructure. It is one component of allowing you to build a platform. So you need to change your mindset and say, like, I don't want to build Kubernetes. I am building a platform. And when I think about building a platform, then I need a clear target for it. I need a clear focus, what it is good for. And then when you get this holistic approach of a platform, then Kubernetes as an underlying foundation will suddenly be an eye-opening component because it simplifies all of the integration part, all of the development part. You can very easily integrate the whole development cycle from the first lines of code until the check, test, deploy, whatever. You just need to integrate once security, you just need to integrate once cost management, compliance, observability. And these platforms are usually extremely easy to reuse, at least if it's some concept which you keep in mind. But when you run this way, when you think a little bit bigger, then you can start comparing also a platform with a cloud provider, because a cloud provider is nothing else than just a platform as a service in the end, which is very, very complicated with tons of other tools. But this is the only level where you can compare. If someone goes with you into the discussion, comparing Kubernetes with cloud capabilities, turn it off. It doesn't make sense to discuss that. Only if you want to think big, and only if you want to go away from thinking small. So how do we find now when Kubernetes is right and what do I need for it? Actually, this question is very complicated because you have a lot of factors in it. I try to pick out 5 very elemental questions to answer so that when you can find an answer to those, you either have a 90% insurance you shouldn't or a 90% insurance you should. The last 10% is up to details. So we have the questions, do you need to introduce it just for one application or is it for the whole organization? How does the application architecture look like? Is it a monolith? Is it a microservices? Is it just functions? Which expectations do you have for the scalability? And does your team have the experience and the capacity to learn? And last but not least, who will run that environment? Now, answering the first question, do you introduce it for one app or the whole organization? If it's one app, frankly speaking, if it's just a simple web application for a handful of people, don't do it. We see one of our clients doing this continuously wrong because someone defined the blueprint Kubernetes is for everything, and especially for web applications, so use it. They reintroduce all the time Kubernetes for running a simple web application, which you can run for, I don't know, $2 a month on a random cloud provider if you want to. But the story changes if you have hundreds of developers and services. If all of them are very small, Kubernetes is a very good choice because you can automate all the complexities around it, simplify the software deployment, and allow a very reliable platform for the simple services. So even if the service is then not that relevant to your organization, you can move it from a bronze class support mechanism to silver or gold standard. Another good direction is when you introduce it for your whole organization. If you strategically plan to implement such a platform for everyone, you have already good direction for it. And it usually will help you to simplify after a while the whole development and operational processes around it. But it's a question of like how experienced you are and how well does things run. So if you have a single initiative, a minor app, and from my enterprise architecture time a few years back, I know that most organizations have this with 80% of their apps or more. You better go for a VM, better for an app engine, container service, or serverless. So how does your application architecture looks like? That would be the next question to answer. If you go for microservices, micromonoliths, distributed applications, and you need something that is fault resistant, that can run multiple times, that can run in parallel and access the same data source and has no problem to be shifted left and right and up and down, it's a good way to go. If you have an application that doesn't fulfill that, and even if it's microservices that are not very good with fault resistancy or not very good with accessing the same data source at the same time, even then, Kubernetes is maybe the worst platform for it. And if it requires a long preheat time to start up, it's also not the right thing to do. As said, monoliths can run on Kubernetes, absolutely no doubts. If your monolith needs ages to get ready to serve, don't do it. Because in an ideal world, the platform team responsible for Kubernetes will never ever tell you when they run an update and can be on the daylight while in production. They just update it and your application should be able to handle that without a problem. Then you're in a good state. Monoliths often can't do that. So this is a clear no-go. And a very large monolith, 1 to 3 million lines of code, is also not a good thing to have it on Kubernetes. Again, it can run there. It's not good to have it there. It will cause more problems in the operational perspective than it brings benefits to you. There's a few little exclamations out of that, which we have seen already in the past, that we enter a project, got told we have a large monolith and that somehow needs to run somewhere in a cloud environment. And in the end, it ends up that this monolith actually has a couple of bigger components. So it's not really one piece of software. It's like 5, 6, 7 larger components that run together. And they are orchestrated, for example, through a messaging system. Those things can run in Kubernetes. Because while you introduce something like a message streaming in between all of these moving parts, it gives you the right reliability and ensures that your system has not a problem with running in parallel most of the time. So you see, it's not that easy to answer that question. You need to go to detail. But this is also the wrong approach if you just talk about one single application. Only if you build if you have the strategic target, let's say to rebuild, for example, Spotify on Netflix with hundreds of microservices where you have hundreds of teams around it, maybe not hundreds, but tens over tens of teams, then this is a good platform. But if we really talk about always single applications, this discussion is already ridiculous. So you need to find the right level, what you're really talking about. Often said this. Also, what is from the cloud environment and cloud providers are often an answer is like, hey, why you don't go serverless? You don't need containers, go serverless. Yes, you're right. Serverless is fantastic. If you just need to go start it. If you want to develop right now an application and you don't want to waste any time, go for serverless. The reality is when this amount of serverless have grown to a huge environment, we see organizations frequently moving away because it becomes too costly. Too costly because of frequent database access, network traffic, API costs. Observability is very complicated and requires some expertise in it. And very often you end up with a question like, okay, this function is now getting called 100 times per hour. Why we just don't run it continuously? If it's the same price, why not? So this demigration from serverless become a thing, but it's not that you should always demigrate. I really like serverless to get started, simple prototype something, have a first application within a few weeks running, and then you can decide where you go. To transfer nowadays an app from one thing to the other is very easy to be done, at least in my opinion. So what's your expectations for scalability? If you need to go from 0 to 100 and back, Kubernetes is maybe a good target, especially if you have events and metrics or triggers that forces you the scaling. But if your expectation that it scales up within a second or less, especially for the hardware underlaying it, then right now it's maybe not the right solution. Even though containers are fast, the underlying infrastructure isn't. The large cloud providers sometimes need a couple of minutes until a new node has started. That varies. We know now some nice infrastructure as a service provider which need less than 30 seconds, but that doesn't count for everyone. And if your app doesn't need more than a container, so it doesn't scale at all, then it's like a thingy in between. Like, yes, you could use Kubernetes, but no, you don't need to use Kubernetes. Especially if you have already cloud environments like AWS, you can go for a container service. Now, you need to be careful. I think that container services have also their own amount of overhead, and not everyone can wrap around the head about how does it work, but it's a good starting point. And if it's a single container, it's maybe even is small enough to fit into a serverless. But if you target a shared cluster with a couple of smaller services, you can also go for that. For me, scalability is not anymore a factor. The question is more about how fast it should scale. If it's extremely fast, it needs to be in a split seconds, milliseconds, you need serverless. You maybe should think about re-architecture for WebAssembly-based serverless mechanisms. They partially can go up to 50, 60 milliseconds to scale up. If you need very fast, okay, we can go with containers and Kubernetes. It has its limits, the limits of the current existing nodes under it, but if you have some room for breathing, it's fast, it's very fast. If you need something which is okay, fast, go with the VM. You need to be careful. There are some service providers which needs minutes. There are some service provider which needs less than a minute. If you need less than a minute, this is service provider. I mean, with VMs are fast. If you need more than a minute, it's moderate. It's very slow. And if you really, really don't care, go for bare metal. Don't mix bare metal with bare metal, but you get the things. And thanks for the Equinix Fox for this nice picture. I really love it. Now, does your team have experience or capacity to learn? And there is just yes and no. If yes, perfect. Give it time, give it room, give it the chance to implement something. You can definitely go for it. If no, you want to finish your platform in 3 months, you actually have just 2 people working on it, the first customer staying there, everything is mission critical. Nope, there will be no chance that this will be successful. because Kubernetes has a very, very hard learning curve. And I found this picture actually kind of cute. There's also another one which is like even going back and then like a cliff where people falling down. I think that's a little bit too harsh on it, because the foundation of Kubernetes is simple. It's very easy to understand. How does it work? You have a platform, you define somehow how your container should run on it. All good. That's a very easy part of it. The complexity comes when you think about the possibility, the extensibility of Kubernetes on top of it, and all the open source solutions which are out there to help you to solve one specific problem at a time. Plus, you need to understand how you manage actually the lifecycle of Kubernetes. It's the most challenging problem out there is the lifecycle management of Kubernetes. It's not to bring apps on it. Also because we see organizations like building platforms very stiff with Terraform, and then we can manage through it. But we see that then the update procedure often is like unsure and like, oh, do we really kill now something, and so on. So slowly coming to an end. For sure, people feel like they have a lot of power if they run Kubernetes cluster. I can prove that, but it's also something which everyone can do. And then who will run the environment? If you have a dedicated team, then the team is responsible for it. Perfect. But if you have a dedicated team that is just there to operate the platform, but not to maintain it, not to develop it, it's maybe wrong, because your team working with it needs to also understand how does it work and how does it goes on. And they need to implement new features in the future. They need to be able to reevaluate if what is implemented is not outdated and can be replaced. This happens very, very frequently, that we need to replace one function with a standard tool because it's not there. So coming slowly to an end, what is the future talking us or showing us? Well, frankly speaking, cloud is a commodity, but already many organizations fail on cloud introduction. So also they will fail with Kubernetes. We will see an evolution of the runtime, and thanks to the colleagues from Cosmonic here, I really like the picture. You can see how we evolved, and we are just like in the middle part with containers and Kubernetes, which gives us a good amount of compatibility. We can run any kind of small, medium, and large workload. It's kind of portable and so on. What comes next is WebAssembly, maybe, as a continuously very cool, safe environment. And this will improve also the security, for example, for a lot of these platforms. And then last but not least, Kubernetes is not the answer to everything. We answered this already. It helps you to streamline things. It helps to focus on the user if you want to build a platform with value, and it will be the foundation for your platforms. Thank you very much. And I think we have a couple of questions.
Yeah, thank you, Max. Unfortunately, we have very few time left. Probably I can ask you one question from Andrei Ignatov. What is your opinion on running stateful workloads in Kubernetes, like database engines? Is it worth the effort?
It's not that complicated with the software-defined network storage, which you usually have, and the possibility that your Kubernetes can reassign the same storage to a database. I think it's not a problem. For me, it's more a question about who wants to operate it and how you manage the service for it. If you're running on a cloud provider and you have a managed service, maybe you should go there because someone else takes more or less care about the database. If you run it on your Kubernetes, you have to take care by yourself, right? But to run it, it's fine. We have seen large database clusters running Kubernetes. They have a dedicated team for it. All good. You can do.
Okay, clear. I guess we have run out of time. We had a few comments in chat, but these are just comments, not questions, I guess. So I guess we will have a small pause now between the next talk. Thank you, Max, for this overview of Kubernetes. And thank you for the attention. Yeah. See you after 15 minutes on next talk.
Thank you. Bye-bye.